Hello friends, I am Professor Pratap N. Shinde. Welcome you all for 8th lecture of Engineering Mechanics. Before proceeding towards the today's lecture, let's recap what we have learned in last lecture. In last lecture, we have solved the two numericals of composition of forces. So in that we have find out, in first numerical we have find out the resultant. The two forces are, so system of forces are given. So there are the 5 forces are given. So that we have to replace by a single force, that is nothing but to find out the resultant. That problem we have solved. Along with that, one problem is given, two forces are given and out of that one is unknown and resultant is given. From that we have to find out the unknown force. So these two problems we have solved in last lecture. Let's coming towards the today's lecture. Today we are going to solve one numerical by using the law of parallelogram of forces and by using the sine rule, that is by using the triangle law. So when we have to use the parallelogram, so when there is only two concurrent forces are there, then we have to use the law of parallelogram of forces. So law of parallelogram forces cannot be used if more than the two number of unknowns or two number of forces, So care should be taken that when there should be only two concurrent forces are given, then we can use the law of parallelogram of forces. So in this figure, it is mentioned in the statement of problem, there are the two cables, cable AB and cable AC is given, which will support this this pole, and the tension in the cable AB is mentioned, that is 500 Newton, and the tension in the cable AC is mentioned, it is 160 Newton, and the height of that cable is 2.5 meter, and it is placed, the point B is placed at a distance of 2 meter from the center of that pole, and the point C is placed at a distance of 1.5 meter from the center of this pole. And they have asked you to find out the resultant of these two cables as well as its location. That they have asked you to find out the magnitude as well as the direction of resultant. So how to tackle this problem? So let's see first solution. So what is given in this problem? First, it is given in the problem, the tension in cable AB is 500 Newton, tension in cable AC is 160 Newton, and they have asked you to find out the resultant in magnitude and direction. As there are the two forces, if you look at on this figure, I have take the freebird diagram, draw the freebird diagram of that figure. The force tension in cable AC, let's say it is P 500 Newton, and tension in cable AB, let's say it is P 500 Newton, and tension in cable AC, let's say it is Q, that is 160 Newton. Our first aim is to find out the angle between the vertical and the cable. So how to find out? Let's say the angle made by the cable with respect to vertical is alpha 1, and the angle made by this cable AC with respect to vertical is alpha 2. So the one side is height is known as well as the front side is known in this triangle. Let's say this is one triangle. Okay. So by applying the trigonometry, we can easily find out this angle alpha 1 and alpha 2. So alpha 1 is nothing but the tan alpha is nothing but the 2 upon 2.5. Okay. So that is opposite side upon the adjacent side. So from that we can find out the alpha 1, that value comes out to be 38.66. Now in order to find out the alpha 2, we are having the opposite side is 1.5 and this adjacent side is given 2.5. So 1.5 divided by 2.5, from that you will get the value of alpha 2, that is 30.96. So this alpha 1 and alpha 2 is now known to us. But where is the location of resultant, that we don't know. Whether it is, but it is fixed that it is always, resultant is lies always in between the two forces. It should not be beyond that line of action of these two forces. So the resultant is always lies in between the AB and AC. In between this portion, this, or we can say that in between the BAC, this portion, the resultant will be there. But where that resultant will be there, where located, that we don't know. So for that same, I have drawn one figure in front of you. So the angle made by the cable AB with respect to vertical is 38.66. Similarly, angle made by the cable AC with respect to vertical is 30.96. So if we add these two angles, I will get the total included angle, that is 69.62. Addition of these two will give you the 69.62. And let's say this is your resultant R, but where it will lies, we don't know. Let's say it makes an angle alpha with respect to the force P. So that we have to find out, that is nothing but the direction. Now by using the formula, what is the formula? R square is equal to P square plus Q square plus twice of PQ cos of theta. What is R? R is nothing but the resultant. What is P? P is the one force. Let's say that force in the cable or tension in the cable AB, that is P. Now the tension in the cable AC, let's say it is Q, that is 160 Newton, plus twice of PQ cos of theta. So please remember this theta. Many students make the mistake in that. Which angle? Theta. Theta is the angle between the two cables or the two forces. So here the theta is the angle made in between these two forces. Let's say the theta is the angle 69.62 that is made in between the force P and force Q. This total included angle is 69.62, that is theta. So substitute all the values in this equation. So R is equal to under root of, I will take, in order to find out R, I will take the square root of all these terms. So P square plus Q square plus twice of PQ cos of theta, that is 69.66. If you substitute all the values, so you will get the value of R, that is 575.59 Newton. That is the magnitude of resultant is now known to us. Again, in order to find out its direction, so we are having the formula tan alpha is equal to Q sin theta upon P plus Q cos of theta. So in this formula, if you substitute all the values, you will get the alpha with respect to P. Whatever this notation, you will get the angle or the direction with respect to this force only. So after solving this, so alpha, substitute the values of all the forces over here, and then you will get the value of alpha, that is 15.10 degree with respect to, this is 500 Newton force. You will get this value of alpha with respect to the P, or P is nothing but the 500 Newton force. So you have get the value of alpha with respect to force 500 Newton, that is P. Now this force, this angle is now known to us. We have find out this angle. Now just this here I have made the question mark, so that is nothing but that alpha we have find out, that is 15.10 degree, that we have find out. So this is nothing but the direction of the resultant with respect to force P. Now if you want to find out the direction with respect to this x direction, what is that angle? Now this is 90 and this angle is given. So in order to find out this angle, if we have to find out this angle with respect to x, or the direction of resultant R with respect to the positive x direction, so how to find out this direction? So 90 plus the total angle is 38.66 minus 15.10, so you will get this angle 113.56 with respect to x. So this is the way to find out the resultant by using the law of parallelogram. Okay.